All right, and welcome to the very first podcast of the year. What is chemistry? I hope you find these podcasts very useful. Remember, you can stop them, pause them, rewind them, view them over and over again, whatever you need to do to master the content at hand. Another little quick word to the wise, if the screen looks a little blurry to you right now, double check one of the settings on your YouTube player. In the lower right hand corner, there should be a resolution box. And if you're on high-speed internet, you can get that all the way up to high definition. I think it's 720. If you have a slightly slower connection, you might not be able to use it at high definition. Otherwise, it'll take too long to load. But at any rate, you can adjust that, and it might come in clear. All right, so away we go. The very first question that we're going to tackle today is, what is chemistry? Great place to start. Very first thing we want to tackle this year. And before we answer the question to what is chemistry, I want to just define one little term here, matter. This is something that you probably learned back in middle school. Matter is anything that has mass. Oh, that's that player. Let's see here. Let's activate our ink and see if that works now. Yep, there we go. Matter is anything that has mass and occupies space. Simply meaning it has substance to it and it has a certain volume. You could theoretically see it, although some things are so small you really can't see them. You might be thinking, well, what is there in the universe that isn't actually some type of substance? And the answer to that is energy. The universe is made up of matter and energy, but predominantly what we look at in chemistry is matter, those things that have substance and occupy space. And so therefore the chemistry then is the study of that matter. Go ahead and fill that in. And the changes that matter undergoes. You can study matter just as it is, but then it's really interesting when you watch it change and it undergoes some type of chemical reaction. Some of them are very spectacular, and others you can't even notice that they're going on. But it's a huge area of science. In fact, it's called the fundamental science because it's used in so many branches, although your physicists might argue against that. But at the macroscopic level, chemistry is fundamental. Now, there are different ways that you can look at chemistry. I'm going to scroll down here and let's talk about some of these different areas of chemistry that you can study. The type of chemistry that we're going to be studying is what's called inorganic chemistry. Inorganic chemistry, as opposed to organic chemistry. Now, organic chemistry is the study of carbon chemistry. So we'll just say carbon-based molecules. But if it's got carbon in it, it's organic. It's a huge, huge branch of chemistry. Inorganic chemistry, the type that we're studying then, is all the chemistry that's not carbon-based. So we'll just say molecules that do not contain carbon. Now, we will study some molecules that have carbon in them. Typically, when you're talking about organic chemistry, you're talking about molecules that might be anywhere between 1 and 100 carbons long or even longer. In organic chemistry, we might talk about a couple molecules here and there that have carbon in them, but that's not going to be our focus. Organic chemistry is typically the second year of college chemistry. Now, another type of chemistry that you could study is biochemistry. Biochemistry is the study of living organisms. And now you might say, well, that's biology. Well, it's going to be the chemistry that takes place inside those living organisms. So go ahead and write in chemistry in living organisms. All right. Now, when you're studying living organisms, you're going to be studying the biological pathways of those organisms, respiration, photosynthesis, all the stuff that goes on inside the bloodstream. If you're talking about, say, humans, for example, that's all chemistry. Now, you can also take a look at analytical chemistry. Now, analytical chemistry is studying the composition of matter. It's got a lot of really, really cool techniques that you can do. In fact, I probably prefer analytical chemistry. It's a lot of testing and number crunching and trying to figure out what these compounds are really made of and why they behave the way that they do. All right. And the last area of chemistry that we want to mention is what's called physical chemistry. Now, physical chemistry is the study of the rate. I'll say rates, meaning how fast reactions go, mechanisms, which are the individual steps that reactions undergo, and then also energy transfers. And we'll study a lot of that in the second part of chemistry, Chemistry B. All right, so those are some of the different areas of chemistry that people can specialize in, and we're going to be touching on a little bit of all of those. Now, in terms of how people do chemistry, there's two different approaches. Number one, you could do what's called pure chemistry. Now, pure chemistry is doing research for the sake of knowledge. People are curious about how the world works around them, and so they simply do research to figure out why chemicals behave the way they do, why they interact the way they do. All right. As opposed to, say, applied chemistry is doing research with a goal or application in mind. We are trying to figure out how we can make a certain molecule behave a certain way so that it can conduct electricity quicker, and we're going to be able to use that type of technology to make electronic devices smaller, for example. All nanotechnology, I want to say all nanotechnology, but oftentimes people research nanotechnology for a particular goal in mind, as opposed to just figuring out why it behaves the way it does. All right? So those are the different areas and the different approaches to chemistry. And the last thing that we want to tackle in this podcast is why we're going to be studying chemistry this year. You might be thinking that yourself, and hopefully I can convince you why chemistry is interesting, why it's fun, and why it applies to you. So the first reason why we study chemistry is because it's one way of explaining the natural world. Again, we're curious to know what this world and what this life is about, and taking a look at chemistry is one avenue to explore that. Another reason why we want to study chemistry is because it prepares you for a career. Most careers, believe it or not, would have some benefit, or most professions have some benefit to having a basic high school understanding of chemistry, whether it's how a certain industrial process works, whether it's why you ship your goods the way you do, how to make things more efficient, etc. It doesn't mean that everybody in, say, accounting has to know chemistry, but if they're working in a particular environment, simply having a general knowledge of how things work would actually make them feel more connected to their particular industry. And finally, we hope that this will help you become a more informed citizen. So we'll just say being an informed citizen. Two of the biggest problems that we're going to be tackling in our lifetimes is energy. How do we make more energy? And the environment. How do we keep our planet clean, safe, and livable? Otherwise, we might be on the extinction list ourselves. Okay? Hopefully that gives you a nice introduction to what we'll be doing this year. We'll see you at the next podcast.